In this video, we're going to investigate what are addition and subtraction. So the directions read, draw a diagram or picture to represent the addition or subtraction problem. Then write the problem symbolically and find the sum or difference. So the first type we're going to look at is an action or change problem. And you're going to notice the next few problems are more than likely going to seem pretty easy for you. And our goal isn't necessarily just to solve these problems, although we're going to do that. We want to look at the structure of the different types of addition and subtraction problems. This way, when we get harder problems later with bigger numbers, we can recognize that structure and use these ideas to solve more difficult problems. So first, let's look at action or change problems. So what happens here is you have some original amount and then there's a change, and the change, which is a result of some action, usually over time, and it could be a gain, a plus, or a subtraction. Okay, and then the result is some new amount. So let's see how this works in the first problem. Now, in general, when you have any application problem, you want to get into the habit of highlighting the givens, that's the information you're given, and the goal, which is what you're trying to find. You could also underline the givens and circle the goal. So in general, I'm going to use a yellow highlighter to highlight the given information. So Glenn has $3, so that's an original amount. He earns $4 mowing his neighbor's lawn. So let's highlight that. That's another piece of given information. So his original amount, something happens, he mows a lawn and he earns $4 more. Then here's our goal, which I'll highlight in green. How many dollars does Glenn have now? Okay, so it's important to know what you're trying to find so that you find the correct amount. Okay, so how does this work? So let's draw a picture. So Glenn started out with $3. I'll draw $3 bills. So this was the start. Okay. Then something changed. He earned $4 more, so that's going to be a plus an additional 4. So we're going to add $4 onto the original amount. And the result is the new amount, which will be all of these dollars combined. 5, 6, 7, or 7 total dollars. Okay, so symbolically, we would write this as 3 plus 4 equals 7. Okay, and sometimes we also like to use units so we know that we're using the correct values. So $3 plus $4 equals $7. So Glenn now has $7. Okay, again, I know this was probably pretty easy, but really think about this structure. So let's look at the next one. Grant has $7, so that's an original amount. Now something's going to happen. He spent $4 on a snack and a drink. And now we want to know how much money he has. How many dollars does Grant have now? So what would this picture look like? Well, his start, or his original amount, is $7. And when the change or the action takes place, he spends $4. So how could we denote that? I'm going to circle 4 of the dollars, and I'm going to write change here. So we take that away. And then we have our new amount is going to be what's left over after we take away the $4, which is $3. So symbolically, we could say he started with 7. We subtracted $4. We took away $4, and the result is $3. Or with units, $7 minus $4 equals $3. So Grant now has $3. Let's look at the next type. So here we have part-whole problems, and we're going to specifically look at two parts making up a whole. Of course, a whole could have more than two different parts, but the idea is, we'll call them part A and part B. A whole can be made up of two different parts that don't overlap, and if you add them together, you get the whole. In terms of subtraction, you could start out with the whole and maybe you know one part and you want to find the other. So we can take the whole and subtract. I'll put part A, it could be part A or part B, it doesn't really matter. And you could find the missing part. So let's see how this works in these problems. So there are 3 boys and 4 girls on the swim team. So that's given information. And we're asked how many children are on the swim team. So this is our goal. So notice there's not an action, there's not an original amount, there's not an action or a change like the last problem. We're basically saying that we have a whole, which is the swim team. It's made up of children. Boys and girls are both children, but we're breaking them into 2 groups. Boys and girls, we could break them into people with brown hair and blonde hair, if that's the only hair colors we had. So we could say, let's use B for boy. So we have 3 boys and 4 girls. Okay. So this is part. Never really matters whether you call them part A or part B. I just want to be able to distinguish them from each other. And when you put them together, you have the whole. And notice we don't say boys or girls now, we're just going to say children. So I'm going to use 1, 2, 3, 4, 5, 6, 7 children. Okay. So in terms of the symbolic representation, we have 3 boys plus 4 girls equals 7. Just put children. Okay. So those are our units, or we could just write without units 3 plus 4 equals 7. Okay. Again, notice this is just like the first problem abstractly when we put it in this representation, the symbolic, but it's different in context. Okay, next one. There are 7 children on the swim team, and then we have 3 of the children are boys. And then we're asked, so our goal, it's usually a question, but not always. It's usually the last sentence, but not always. So how many girls are on the swim team? That's what we're trying to find. Okay. And it could say determine the number of girls on the swim team. So it doesn't have to be a question, but frequently it is. So what does this look like? Okay, so the swim team, the 7 children are our whole. So let's start with the whole. We have 1, 2, 3, 4, 5, 6, 7. Okay, and we're told that 3 of the children are boys. So let's see, I'll write 3 boys. So this is a part. We'll call it part A. Okay, and these 3 children, or any 3 children, will match up with the 3 boys, and then we know the remaining part which is going to be the girls, are these 4 children, which we'll use G's for. Okay, so this is one part. Here's another part. Okay. And these 2 parts together make up the whole. And we found the number of girls. So we could write 7 children minus 3 boys equals 4 girls. Okay, so that's with our units. Or we can write abstractly 7 minus 3 equals 4. Okay, now let's look at the last type. So here we have comparison problems, and the idea here is we are comparing two amounts. And if you have two numbers and they're not the same, we'll say one amount is more and one amount is less. And we also have something we call the difference between the two amounts. So I'm just going to put comma, difference. Okay, so this is the structure here. Okay, so let's read through this problem. Lara has 4 more goldfish than Owen. Owen has 3 goldfish. We want to know how many goldfish does Lara have. So that's our goal. Okay, so here we're told this value is the difference. One is more and one is less. So Lara has 4 more goldfish than Owen. So I'm going to write under here, this is the difference. We're comparing the number of goldfish Lara has and then Owen has. Okay, this is Owen's amount. We'll just put Owen's fish for short. Okay, and we want to find how many fish Lara has. Okay, so let's draw a picture. Okay, let's start with Owen's fish. So Owen has, sorry, that's the best I can do for fish. Owen has 3 fish. Okay, the difference is, let's make this a different color, 4 fish, and we want to know how many Lara has. Okay, so since Lara has more, these 4 more, then I'll put over here that Lara has, actually we'll put it over here, the same number of fish as Owen plus an additional 4 fish. Okay, I made them different colors because notice, unlike the other situation, we're not taking away any of these fish from Owen. Okay, we're comparing these different sets of fish, these different amounts. Okay, so abstractly we could say that the number of Owen's fish plus the difference equals number of fish that Lara has. Okay, and now looking at the last one, Lisa has 7 goldfish and Oscar has 3 goldfish. And we want to know how many more goldfish does Lisa have. Okay, so here we're comparing two amounts, Lisa's fish and Oscar's fish. This is Lisa, this is Oscar, and what we want to find is the difference. Here we were given the difference. So what might this look like? Well, Lisa has 7. 1, 2, 3, 4, 5, 6, 7. Oscar has 3. Let's make those blue. Okay. And our comparison is we want to see how many more does Lisa have compared to Oscar. So we could think of making a matching, comparing Lisa's fish to Oscar's. Okay, so these match up, so Lisa has 4 more. Okay, and we can find this symbolically by finding the difference between Lisa and Oscar's fish. So we could take 7 fish that Lisa has minus the 3 fish that Oscar has. Okay, we're not taking away the fish from Oscar, we're just comparing, which gives us 4 fish more that Lisa has. And this is our difference. Okay. Now to sum up, we have a little chart here. This is in your media lesson packet. Okay, and we'll be looking at these in the next problems, which are a little bit harder. We're going to use bigger numbers. They're not going to be as straightforward. But these are the basic structures we're going to use. You don't have to memorize these, but if you can recognize these structures in a problem, it will help you solve them.